Well, first, actually, I would like to just say that we're going ahead with our speaker now, and could we please all put questions into the chat box? It would be great to keep muted. Dean will collate the questions at the end of the talk, and we'll read them aloud and have Brendan answer them. So at this time, I'd like to welcome Nature Guelph member and a founding member of Faith Light Awareness Program, or FLAP Canada, Paloma Plant, to introduce our guest speaker. Paloma, are you there?
Hi, Val. Yes, I'm here. Hopefully everyone can hear me.
Yes.
I'm just letting you know I have thunder and lightning, so if I get cut off, you'll know why. This is normal for living in Erin, but that's country life. I'm very, very pleased and honored to present Brendan as a speaker this evening. Brendan is a PhD candidate in the Department of Biology at Western University and works at the Advanced Facility for Avian Research, or AFAR, where he studies the biological mechanisms of why birds crash into windows. Brendan holds a Bachelor of Science in Psychology from the University of Guelph and a Master of Science in Neuroscience from Western University. He volunteers for several nature organizations, including Nature London as a chimney swift monitor, London's Environmental and Ecological Planning Advisory Committee, and something close to my heart, FLAP Canada. He's
Paloma, I'm afraid we've dropped your sound. Paloma, are you still out there? Well, I don't know if I should just wing this, or Brendan, perhaps I should let you finish the introduction.
This is the new reality we find ourselves in.
Yes, indeed.
No problem. I can finish off where Paloma left off, if that's okay with the group.
For sure.
So like Paloma said, I'm a PhD candidate at Western University. I did my undergraduate degree at the University of Guelph, and so it's great for me to be sort of coming back to Guelph in a virtual sense to talk about what I've been up to lately. I do a fair bit of volunteering in the environmental sector, as Paloma mentioned, and I'm a person who cares deeply about the birds, but lately I find myself thinking more critically about the human dimensions of this problem of birds flying into windows and buildings, and how we solve that by understanding how birds work, but also how we change people's minds and their hearts and convince them that this is worth doing something about. So I'm going to share my screen and we will jump right in. Just a second. You would think after a year of this, I would become more effective and efficient, but okay. I think we're good. So can you see my title slide, everybody?
Yeah.
Okay, great.
Yes, we can.
Excellent. All right. So pleasure to be here. Thank you very much for having me. I'm really excited to talk about my research. This is a really complicated topic. I know it's sort of counterintuitive. A lot of the time I talk to people who have only just learned that birds fly into windows and they think, really, you're doing a whole PhD about that? That seems excessive. But there is a lot of nuance to it. I'm going to aim to try and impart you guys with useful information that you can apply in your own daily lives, such as fixing the windows on your homes, but also telling you about, at a high level, the research that I'm doing and how I hope to see that research translate into policy and meaningful change in the world. I want to also just acknowledge you guys have a wonderful group in Guelph called Bird Safe Guelph, which I'm sure many of you are already familiar with, that are doing tremendous advocacy and public education about window strikes and how to prevent them. So I would encourage you to keep up with that Bird Safe Guelph group in case there's anything I missed today. But FLAP Canada, through their birdsafe.ca website, has great information as well. So with that disclaimer in mind, I'm going to again try and impart you with a fulsome understanding, but there's a lot of ground to cover, so let's jump right in. And I'm actually just going to set a timer for myself because I find when I talk about my PhD, I can get a little overboard and I don't want to keep you guys here all night. So let's get into it. So the title of my talk is what bird vision and behavior can teach us about preventing window collisions. So this is the moment I think about all the time. It's a bird, you see a bird's eye, and reflected in the eye is the image of a window. And I imagine that this is what a bird experiences in the split seconds right before a collision. And in my opinion, to solve this problem, we need to really try and get into a bird's head and understand what it is perceiving and what it is doing in those split seconds if we want to effectively prevent collisions from happening. I also think about that situation, birds being, confronting a window and not knowing what to do with it in the context of birds' life history. And really, we need to start recognizing that windows are this very artificial thing that do not belong in the landscape that birds have evolved in. So what I've shown here is a picture of what southwestern Ontario, including Guelph, might have looked like just a couple hundred years ago. This you might call Carolinian forest or eastern deciduous forest. And basically how birds work as we know them today evolved under these conditions. And so they are very well adapted to thrive in an environment like this, and less so in an artificial built environment. Where I live in London, Ontario, it didn't take very long for people to heavily modify the landscape. So in 1872, somebody drew this map of what London looked like. It was pretty small back then. It's exploded since. But it was around this time that people started using windows on buildings, so glass. But it wasn't such a concern for birds because most of the windows looked something like this. If you could afford to have glass on your home, it wasn't a substantial thing. My university, the University of Western Ontario, sprung up a few years later, and it had two buildings and they looked like this. Not crazy amounts of glass like we see today, but a moderate amount. And actually, coincidentally, it was around this time, I think in 1874, that the very first records of birds crashing into windows appeared. That came overseas in Cambridge, where somebody had documented, I think it was a hawk flew into a greenhouse trying to get at a bird that was inside. So collisions have been around for a while, but back then there wasn't so much glass that birds had to be concerned about. So if we fast forward to now, this is what the city of London looks like today. And obviously the landscape has been heavily modified. It's much more anthropocentric. There's just a lot more built stuff. We still have trees and habitat, and birds do still live here, but a very different reality than the birds evolved in. I want to use this image to highlight something that I think leads to a lot of misconceptions about collisions and where they happen. So in London, we don't have that many high-rise buildings. We've got a few more than in Guelph, but there's this one building called One London Place, which is a giant mirrored glass box. And when I talk to people about window collisions, they tend to sort of point the finger at this kind of structure and they say, oh, those big glass skyscrapers, right? Like killing all the birds. And actually, that's not true. Most of the time birds are hitting windows, it's not at these high-rise buildings, it's actually at low-rise buildings and homes. So a study published in 2013 looked at collision mortality across Canada, and they found that the vast majority of collisions, like I said, are happening at these low-rise buildings and homes. And the reason for that is straightforward. There are just far more low-rise buildings and homes than there are high-rise buildings. There's other aspects of this that I'm going to talk about next, but we really need to think about window collisions as problems in all of our neighborhoods and not just high-rise buildings in our city centers. So these are some of the buildings that have surfaced in London in the time since the 1800s. In fact, all these buildings here are ones that are on my university campus, and I monitor these buildings looking for places where birds strike the glass. I'll talk a little bit more about that towards the end. But I'm sure this group can recognize that this is a very widespread problem in the world today. We see more and more glass structures appearing all over the place. So what are we going to do about that? And it's not just London. I mean, I went online and it took me 2 minutes to find examples of reflective glass buildings in Guelph. On the left, you've got your city hall, the Civic Museum in Guelph, and then the giant science building at the university campus. All of those have reflective glass windows that pose some amount of danger to birds. So why do birds hit windows? The group might already be a bit familiar with this since, like I said, you have this amazing advocacy group, Birds Safe Guelph, talking to you about this all the time. But just for the purpose of framing my talk, a few things to point out. So most of the time birds hit windows, it's happening during the daytime. And the reason for that is because birds do not understand the concept of reflections when they appear on glass, or glass might appear transparent and birds will try and fly through it because it's just invisible. They don't know it's there. But I think the reflection problem is more significant and causes most of the collisions. And so in situations like I've shown in this picture, this is a building on our campus, birds will see a reflection of a tree and they think it's the real thing. So they're trying to fly towards that extension of their habitat. And for that reason, most of the time collisions occur, it's at or below the height of the surrounding tree canopy. So that's up to, in most places, the 4th story of the building. And that makes sense because during the day, that's where birds are hanging out. If they're migratory species that are passing through, you know, they're in their stopover territory, they're looking for food and shelter. And so it's really those first 4 stories of the building that are the most dangerous for birds. And that's part of why high-rise buildings are less a problem for daytime collisions. Now, I don't want to totally ignore nighttime collisions because they do play a role, but it's thought that the mechanism of how light pollution at night causes collisions is rather different than during the day. So here's the same landscape of London, Ontario. And what I want to point out here is there's a lot of glow up into the night sky because we leave a lot of our lights on from our infrastructure. In fact, you can see this phenomenon from space. We've got an enormous amount of light pollution in North America, and it's not only a problem for birds in terms of causing collisions, it's a problem for all kinds of natural processes. You know, all the animals that are courting at night or trying to sleep at night can be disrupted when we leave our lights on. And so one really striking image that I've included on the right here, this is the World Trade Center Memorial in New York City. And what you see are these 2 beams of light that project up into the night sky. What they were finding after a couple of years of this installation being turned on was that during migration, birds would start to accumulate around these lights. And if you look carefully, the little tiny white specks are actually birds that are caught in the glare being shone up into the night sky. And they would just circle and circle over and over, some of them collapsing and falling down from exhaustion, other ones crashing into buildings. And so now there's this procedure where they monitor how many birds are in the night sky when this installation is active, and they'll turn the lights off to allow the birds to pass through. And so that's the take-home message I want to leave you with about nighttime collisions. I've illustrated it with this comic here that I drew for Flap. Birds need to be able to see what's going on in the night sky as they're flying, where the stars are, where the moon is, you know, where the sun is rising and setting. That's a really important cue for them to know where they're navigating so that they can migrate to their destination. When they reach a city center like downtown London or downtown Guelph, and there's a lot of lights left on, those cues are less available to them. And so it can lead to all kinds of disorientation where they're following the light, but they don't really know where they're going. And that is where they're at increased risk of collisions. The simplest solution for that really is just turn your lights off if you can. Light timers are a wonderful thing, so you don't have to remember to do it. Many municipalities are now requiring that outdoor fixtures only point light downwards. And so this is, I think, a more straightforward problem that we can solve in terms of preventing collisions. So I want to move on and talk about my area of focus, which is collisions during the day. And I mentioned municipalities are now starting to pay attention and introducing rules for developers that will support bird-friendly design. So what does that mean? In the city of Toronto, in New York, in San Francisco, and recently even in London, where I live, we have new bylaws and guidelines that are requiring developers or encouraging developers to use bird-friendly materials. And typically what's meant by bird-friendly material is certain treatments on glass that get used in construction. So what exactly is bird-friendly glass? This is the crux of what I study. Basically, I define it as materials that reduce the risk of bird collisions if used on or in place of traditional plate glass. So windows on buildings. It can also be things like bus shelters, railings that are made out of glass, that kind of thing. And there's two main categories to think about. There are materials for new construction. So if I'm building something new in a municipality that requires it by law, then I have to use bird-friendly materials. But then there are also separate materials that are for retrofitting existing buildings. A couple things I want to point out. Most of the time birds are hitting windows, it's on existing buildings. It's not new buildings, it's all of the glass that's already out there in the world killing birds. The problem is that all of that glass that poses the existing problem is beyond the scope of enforcing a bylaw. So there's no way, there's no framework to make people fix their window, even if it's killing a lot of birds. And so that's why I've mentioned here that these retrofits are voluntary, and we really need to come up with ways of convincing people that this is worth doing through education and showing them the problem and solutions. So I'm going to talk about those solutions, but I always think it's easier to start from a place of describing what does not work, the anti-solutions. And the reason for that is because in this space of acknowledging and preventing window collisions, unfortunately, in past decades, we got off to a bit of a rough start where we were popularizing these ways of fixing windows that don't actually work. And we know that now because of science, but these seem to have kind of lodged themselves in public consciousness of the issue. And so a lot of the things that I talk about are towards dispelling this misinformation. So what do I mean by that? You may have seen this product. It's called Window Alert. They have different variants of it now, but at the core feature of the product is that it's using this material that reflects ultraviolet. And the claim is that because birds can see ultraviolet, but people cannot see ultraviolet. And when I say ultraviolet, I mean certain wavelengths from the sunlight that are in the ultraviolet spectrum. Birds have extra cells in their eyes that make them sensitive to that type of light that people don't see. But the claim is that because birds see it and people don't see it, if you put this on your window, it's going to really stand out and birds aren't going to crash into it because they'll recognize, oh, there's something here, but it's not going to disrupt your view out the window because UV is invisible to people. I love the concept. I am not convinced by the science whatsoever. There's very little research that has actually shown conclusively that these kinds of ultraviolet treatments do stand out to birds and are going to be effective. In the case of Window Alert, there's a second problem, which is that the manufacturer says you need to replace this every 4 months because the UV is going to fade if it's used on a window outside. And so people are putting stickers up on their windows thinking, oh, I've solved the problem. But in fact, they need to continuously go back 3 times a year to replace those stickers. And nobody ever does that. So I would encourage you to probably avoid ultraviolet window treatments if you can, including Window Alert. So this is another common thing I see people do to try and prevent window collisions. And I drive around town and I see this up on people's houses and I feel kind of bad for them because they're trying to do the right thing. This is what they know. But unfortunately, this does not work. So people will try and put these single individual silhouettes. These stickers are, hummingbird or a butterfly. A popular one also is a bird of prey. Some people seem to think that it will scare birds away based on some study 2 decades ago that made no sense. I don't like this method, and I'm going to show you why. So if I was a bird and I wanted to get through this, to get to that tree in the background, for example, there's these 3 objects in my way. I can just go around them. And in fact, birds are really good at this because of the environment in which they evolved. So to illustrate what I mean, birds can do this. If there are obstacles in a bird's path, they can swerve, they can duck in between them. This is no problem. There's been a few studies that have shown that birds are very aware of how wide their bodies are with their wings outstretched or closed. And if you give them a narrow aperture like this, they'll tuck their wings in to fit through it. And so I imagine if a bird had, stickers, it could just fly around them or between them. If you wanted to use that method effectively, you would need to basically coat your window in these stickers, and it would cost you a lot of money. And frankly, it would be hideous. So I don't think this is the best solution. Another thing that people will do is they'll just close their curtains on the inside of the glass and call it a day. And the reason that does not work is because it doesn't dampen the reflection on the outside of the glass. And so really we need to concentrate on treating the exterior of the windows and not the interior. This is another one that makes me scratch my head. People will put these decoy statues of owls, or I've seen hawks too, thinking that it will scare birds away. Maybe it's because people have this idea of a bird brain and think birds are dumb. They're not dumb. They know this is an inanimate object and they'll probably just poop on it and ignore it. So I would spare yourself the trouble and don't use this method. At least not for preventing window strikes. You might be able to keep them off your window ledge, but this person apparently had no luck. So what does work? I feel like that's probably looming in everyone's mind. There are 4 general principles that I want to impart you with for how we should treat windows to be effective so that birds will see the treatment, detect it while they're flying, avoid it, and not collide. First of all, like I said, markers have to be on the outside or exterior first surface of the glass. That's to break up the reflection. If they go on the interior, you're very likely still going to have reflection. Markers need to cover the entire window surface edge to edge. So it's like that example of the stickers, the black ones in different shapes. If you only put a couple of them on there, then birds are just going to fly around them. They should be spaced no wider than 2 inches apart. I'll talk a little bit about that next. And markers should provide high visual contrast against the background. This last one is something that I look at in my research. I'll talk about that shortly. It's not well defined what visual contrast means just yet, but a good way to think about it is if you've got a dark window, when you're standing outside and let's say looking at your house, if the window appears dark, and most often it does because the light behind the glass is going to be lower since it's covered by a roof. If the window appears dark, what you want to put on the glass should be light. So white dots or white lines on a black window is going to achieve that contrast. Or if you have, let's say, a glass fence and you have the same amount of light on either side of the glass fence, putting something black might be more conspicuous. It might stand out and provide that contrast because the glass is going to appear lighter. So I talked about that 2-inch spacing, and I just want to highlight why that is the case. This actually shows 2x4 spacing, but the idea is that if you leave gaps no wider than 2 inches apart between markers, so dots or lines, then birds that are really small are not going to be able to fit through that. So common examples we have in Ontario are ruby-throated hummingbirds and ruby-crowned kinglets. Both of these are prone to hitting windows. If you put markers up that are 2 inches apart, there's no way a hummingbird or a kinglet is going to try and squeeze through them. Whereas 4-inch spacing, they might. This is sort of speculative, and there's not a lot of research which shows that 4-inch spacing is inferior to 2-inch spacing, but it's what I recommend just to be on the safe side. Another really important thing to highlight is where you position your feeders can make a big difference for collision risk. So Flap Canada recommends putting them within 3 feet of the window. And the logic there goes, if a bird is at your feeder and it takes off, it's not going to have enough time or space to gain speed that could cause it to hurt itself against your window. If it hit the window, it would be traveling pretty slowly and it would probably just bounce off of it. So I want to just show you a couple examples of DIY. BirdSafe Guelph has lots of these, but just to illustrate some of the concepts I've been talking about. Feather-friendly DIY. Oh, I've got where you can buy it in London. That's probably not useful for you guys. This comes in a little roll of tape, and if you put the tape on in strips, like in the top left, sorry, I think I was muted. If you put strips of the tape on, it leaves behind rows of dots, and then you can peel it off and it leaves the dots behind. I have this on the window right behind my computer. I'm looking at it right now. It's pretty inconspicuous. You don't notice it after a while. Super durable, highly recommend. It costs about $15.99, I think. You can also just use tape. So if you're in a bind and a bird just hit your window and I want to fix this before migration's over, putting on strips of tape every 2 inches, even painter's tape is fine. There's more sturdy tape. So like automotive tape, for instance, you can buy on Amazon or Canadian Tire. There's dedicated products. So this is like a translucent tape. People have gotten creative with tape. A common problem with glass at zoos is that new animals in their enclosures will try and fly right through the glass barriers. And so here's something, a mural that somebody created using masking tape. So there are opportunities to get creative. Here's bubble wrap. I wouldn't put this on my house, but it does provide that coverage. And maybe you'd be safe if you were accidentally the sort of person to run into your house. But again, that uniform coverage, creating a nice pattern effect. This is another popular solution called Acopian bird savers or Zen curtains. So here's some larger installations. It's hard to tell from these photos actually, but basically these are pieces of cord suspended from above the window every 4 inches apart. Here's examples at home. So in front of a sliding door or a window with a feeder nearby. This is really economical. My experience with these is they do blow in the wind a little bit. So if that's a nuisance, you might want to put a bar at the bottom just to fix the cords in place. I've also heard of people putting beads on their cords and creating sort of a curtain. I mean, there's nothing wrong with that, but just be mindful if you do adopt this method, it might rattle a little bit against the glass. So choose soft beads or place it a suitable distance in front. People get creative in other ways. You can paint or draw. Like I mentioned before, it does have to go on the outside of the window. And then, of course, there's lots of stuff that you can do with markers. I'm actually doing a little experiment right now in my backyard where I went out and purchased a whole bunch of different types of markers, including this one. And I drew on some panes of glass, and I'm just going to leave them outside for a year because I want to see which is the most durable. No one really knows if it's acrylic or oil-based or wax pens, what is going to last the longest on windows exposed to sunlight and rain and that sort of thing. So the jury's out on that one. But if you choose a marker like this, you can go crazy with drawing all kinds of things. So people have done amazing stuff using their windows as a canvas. I've seen this on different university campuses and residences. So here's just some, creative pictures for inspiration. Somebody instead got a roll of different stickers. I think this was around the time of Pride, and put up rows of dots. Another method that people use is putting up screens or netting. And this one sometimes I get a little perplexed by. The idea is that if a bird hits a screen, it's going to bounce off it safely, as opposed to hitting the glass. I'm not so convinced that this actually stands out to birds enough that they recognize there's something solid here I can't fly through. But ultimately, if you're trying to keep birds safe, this method is worth considering. So just scaling this up a little bit, the same principles apply to bigger structures. There's a tennis court in the top left, transportation shelters. This is really picked up in Europe. That's where these photos are from. The University of British Columbia has gorgeous fixtures of birds. Same with other universities across Canada. We're seeing more and more people expressing creativity and using windows as a canvas. Here's a museum out in BC with a custom film. And sometimes putting stuff up on the building, on the glass, actually enhances the aesthetics and tells people this is what this building is. So I believe this is a wildlife rehabilitation center. And you can tell just from looking at the glass, and you're also helping birds with that. So I've talked mostly about retrofits for existing buildings because I figured that would be most relevant to your group. But I still haven't really talked about, how do we know what is bird friendly and what isn't? And that is what I study. So that's most relevant to me and what I spend my time thinking about. And so to describe my research first, I think I need to talk about the way that we got to where we are and how we know what is bird friendly based on evidence. So you may have seen this if you've ever shopped around for a bird friendly window treatment, such as feather friendly. This is a little endorsement from an organization in the United States called American Bird Conservancy, and they are sort of the leader in North America, at least, for testing these products and establishing what is effective and not for preventing window collisions through their Bird Smart Glass program. So what does that program actually entail? They have this apparatus that they call a flight tunnel. It's located at the Powder Mill Nature Reserve, I think in Pennsylvania. And this is what it looks like from the exterior. I'm going to walk you through what is going on in these 4 panels. So in the top left, there's a woman holding a bag. And inside that bag is what I presume to be a pretty unhappy bird. Birds don't like being inside bags. In the top right, you see a woman in a blue sweater taking a bird from her hand and releasing it into the tunnel. And if I was the bird, what I would see leaving the hand is shown in the bottom right. I'm inside this long dark tube and I'm trying to fly, forward to get out of there. And at the other end of the tunnel, you see what's in the bottom left. There are 2 panels of glass. Usually one is plain and one is treated with some pattern or something. And they are comparing, does the bird fly to the left side or does the bird fly to the right side? So I can catch my breath because I talk really fast. I'm going to play you guys a really quick video clip which demonstrates how the tunnel works. They're thrilled to be participating in this study. I'm going to come back to this method in a second, but I just want to show you that a similar protocol has been developed overseas in Austria, where they've built another equivalent flight tunnel, and they're also testing birds by flying to the left or flying to the right. They use mirrors at the end to reflect the surrounding green space. There's one final method that's used in the United States for testing how effective different treatments are for preventing window strikes. And that is what we call the field method, developed by Daniel Clem Jr., I believe also in Pennsylvania. They basically put these panes of glass in frames standing up in a field. They lay out these platforms with food on them, and they wait and see how many birds show up and smack into them and die. It's pretty brutal. And a lot of people are sort of unhappy that this is the cost in birds' lives for establishing what works and what doesn't. So before I move on to my research, I want to highlight a couple things about these methods that I find a bit problematic. We are still not thinking about how birds see these things. We're just popping them in and into a very artificial space that's dark. Birds are terrified because they're being released from the hand, and we're using their behavior under those very specific circumstances to assess how effective materials are at preventing birds from crashing into real buildings in the real world. There are other problems with the flight tunnels. I'll spare you the details unless you want to hear about them later. But looking at this field testing method, again, we're relying on killing many birds in order to assess product, and I feel like that's not a sustainable option. So my core interest is testing hypotheses. I'm a scientist, right? And my hypothesis is that the risk of bird window collisions is related to how birds see windows on buildings, and also how birds see window treatments. And in thinking about how birds see, we have to recognize that birds' vision is very, very different from human vision. People look at a glass treatment and we have no way of telling with our own eyes what that's going to look like to a bird. So for example, the 2 figures on the right are showing the ways that birds can see ultraviolet, like I talked about before. They have a 4th type of cone cell in their eye that lets them see into the ultraviolet spectrum. Birds have a higher density of photoreceptors at the center of their eye, so that gives them better visual acuity than people have. But on the other hand, most birds have less contrast resolution than people do. Another interesting thing, at the very center of your eye, a human eye, you have what's called a fovea. It overlaps with your pupil. And if you were reading a book, you would be pointing your fovea at what you're looking at, what you're reading, and it would give you the most detailed vision, right? Birds actually have 2 of those in each eye. they've got kind of a figure 8 phobia. And what we think that's useful for is if they're on the ground feeding, they can be looking at the ground, foraging, and also keeping an eye on what's in the sky, making sure that they're not becoming somebody else's dinner. So these are just a couple of ways in which birds' eyes are really different from ours, and we need to factor that into how we're designing these products. So some questions that keep me up at night, literally, what are the properties of window treatments that are most important here? How does visual sensitivity to these treatments compare across different bird species? How do birds actually see what's coming up in front of them while they're flying really fast? And for that matter, how are birds even hitting windows? Most of what we know about window strikes comes from going around and picking up bodies. Actually documenting what's happening in those critical seconds before a collision is anybody's best guess. So another really important aspect of bird vision that I've been thinking about is how birds are pointing their eyes. Another big difference between ourselves and birds is that most birds, like passerines and pigeons, have eyes that are lateral. They're on the sides of their head. And what that means is their visual field gives them much wider peripheral vision than we have, but their frontal eye vision is not so great. And so with a pigeon, you have these two different types of vision, binocular and monocular. Binocular being they use two eyes. That's like if they were looking at something right in front of them, if they were trying to peck at something on the ground, they're using that narrow overlap like you see on the left between the eyes, versus on the right, you have monocular vision where a bird will turn its head and look forward with one eye. So what does this mean for collisions? Oh, this is just a comparison with how humans see. We have much more binocular vision because we have two eyes in the front. I wanted to study this a little bit, and I wanted to document what collisions look like in the real world. So a couple years ago, I set up these cameras in a backyard space where they're basic home security cameras, and we were just filming birds interacting with the windows passively over the span of a couple migration seasons. The left picture just shows where I put the cameras, the orange hexagons, where the windows are, and then some measurements I took so that I could calculate how fast these birds were flying and their angles of flight and that sort of thing. So we caught some cool footage. For example, sometimes when birds approach the windows, they actually figure out what's going on and they can swerve and avoid them. That was the blue jay coming in hot. And so there are an untold number of collisions that never actually occur. And no one has ever really been able to capture that before. In other cases, we did see unfortunate lethal events. So this was a northern cardinal that flew into a window rather fast at a perpendicular angle and instantly died on impact. I know it's distressing to look at, but this is really important footage because, again, no one has ever actually captured window collisions systematically in the field before. So a few findings. We noticed that most of the time birds hit windows, they're actually flying away right after. Like there was another cardinal, no body left behind. So when we're estimating collisions by bodies left on the ground, that's probably a severe underestimate. Another interesting thing from that clip is the cardinal came in from a really wide angle, right? And most of the time we think about collisions, we're imagining them hitting perpendicularly, but that's not the case. And so thinking about how birds see glass, the reflection is going to depend on where they're coming from. So one other thing I want to show you real quick, because I was talking about how birds are pointing their eyes. This is not a collision, but it's an incidental clip that I captured. This is an oriole, and you're going to see it fly in, and the oriole lands on this little perch here, and that was really fast. So I'm going to slow it down for you. What's happening is this oriole is flying towards our camera on a tripod. And as it gets close, the oriole's like, wait a second, there's something there. And the oriole turns its head and it's focusing its one eye, its monocular vision, where you have the greatest acuity on what's in front of it. And only then does it actually swerve and avoid hitting into the camera. I've wondered, is this what birds are doing when they're successfully avoiding windows? And if that's true, we need to think about modeling how birds see this stuff based on the part of their eye that's actually involved. So my PhD project at its core is, how do we simulate collisions with windows in a way that is natural, resembles what collisions are like in the real world, but still provides us with experimental control so that we can answer our research questions and be confident in our data. This is where I work. This is the Advanced Facility for Avian Research at Western University. They filmed clips of The Messenger. I don't know if you guys have seen that movie, but where you see birds flying in the dark. That footage was obtained in our hyperbaric wind tunnel shown in the bottom left. Really cool state-of-the-art equipment that simulates what birds experience when they're flying way up in the atmosphere. I could rant about it, but I'm short of time, so I'll move on. And what I'm doing right now is I'm going out and I'm capturing house sparrows, these wild little beasts that nobody seems to like except for me. And I am doing these miniature experiments with them to see how they behave in a flight arena space. So here's some that I had brought in from the field. And so this is what I like to call our pilot tunnel, or the Home Depot tunnel. I like the name Home Depot because I actually catch a lot of my birds at Home Depot. So I like to say all my materials come from them. We built a miniature version of this long tube, kind of like what they're doing in American Bird Conservancy's video, the tunnel in the video I showed you. And so what happens is the birds enter through this little hole at the beginning, and they fly towards the end where they would end up inside of an enclosure. And before they reach the enclosure, there's actually a lightweight piece of plastic. This is just window insulation film that we have in a frame. If the bird hits this, it's pretty elastic. So the bird will just safely bounce off of it, the frame tips over. So this is how we started doing this, because I couldn't use real glass yet and the birds had to be kept safe. And what we're trying to do is we want to sort of build a mechanistic model of what those birds are doing in the moments leading up to a potential collision. So here we've treated the plastic with feather-friendly dots, and we have been capturing, using high-speed cameras, how birds are behaving in those critical moments leading up to impact. Are they detecting what's going on? Are they changing their flight path? That sort of thing. So this image, which was on the title slide of my talk, is one that we obtained with this method, where a bird was approaching, it did not detect what was going on, and it swerved, and after it hit it, it managed to stay afloat. But using this approach, we can capture variables like how fast birds are flying and are they changing their flight path. But obviously, this is plastic. This is not a real window collision. This is just our starting point. I want to show you just a clip of what this might look like. So here's a house sparrow I'm about to release into the tunnel. And you can see it avoids it. It realizes I can't go through that opening, and it swerves to the top and ends up landing on a perch. Here's another clip of a bird being rather cheeky. The bird comes close, it realizes, oh wait, there's something here. It looks into the camera, winks at me, and flies off. They're very clever things I'm finding. So ultimately what we want to do is we want to simulate collisions in a natural way, right? Not inside a plastic tube inside of a room, but actually outdoors in an environment that resembles what birds would experience if they were approaching a window in a backyard, for example. And so this is something that I'm hoping to work on over the summer. It's been a bit delayed by the pandemic, but hasn't everything. And so this is what I'm thinking of building. I'm going to walk you through this diagram. It's a little bit scary. The idea is that rather than releasing birds from the hand, we put the bird inside of an enclosure. We let the bird sort of hang out in there until it's calm, and then we let it start the flight by itself. And as the bird is flying forward down this tube to escape, it has to choose, like in the other tunnel, to fly on the left side or on the right side. Now, as the bird is flying forward, its behavior is being captured by 3 cameras, and they're positioned where you see these red stars. Those cameras have a very high frame rate, and they're synchronous. So we are able to see what birds are doing all the way through a trial. The really important piece is we cannot be killing birds by having them smack into the glass. And so we've created a new mechanism where the bird flies through what we call a light curtain. It's actually an array of infrared sensors. And when the bird breaks through the sensor, it sends a trigger pulse to this mechanism that will cause the net at the end of the tunnel to shoot up from below. And so what this does is it allows the bird to fly forward towards the glass without the net in its way, so that it's actually looking at the glass and not glass behind the net, because the birds might actually see the net and avoid that. The bird passes through the beam, and as soon as that trigger is sent, it forces the net up from the ground and it captures the bird safely to keep them from being harmed. So that's the basic concept of the flight tunnel. Under this configuration, we would call this a transparency or transmission test. And the reason is because if a bird were looking at the glass at the end, it's going to be transparent, just like on American Bird Conservancy's tunnel. You would see right through it. But we also want to be able to test reflections. And so a second configuration of this tunnel will probably look like us mounting the glass on some kind of shed where there's a roof behind the glass, and it will cause the appearance of the glass to be more reflective because it's darker behind. A really important other piece of this that I forgot to mention is that there's not going to be, really dark walls and ceiling on this tunnel. We're going to allow in as much natural light as possible by having the top be made out of chicken wire. And that way we are properly simulating the way that birds would experience daylight and reflections in the real world, which is something that previous tests have not been able to do. So all of this to me is about designing this based on bird vision. And so I'm going to try and fly through this part because I'm cognizant of the time. Testing these things is important, right? We want empirical proof. We want to show what birds are doing and behaving in the way that we expect them to. But how do we form those expectations? I think the way to do that is through what I like to call visual perceptual modeling. So for example, there have been these studies where they take a species of bird and they define everything there is about their vision. They know what colors they see, they know the angles that they see, all of these important details that are relevant to us. And what we can do is we can take these parameters, this detailed information about how birds see, and we can train a computer to see like a bird. I know it sounds unbelievable. It's possible, I promise. What we want to do is if we can get a computer to predict for us what birds can see or not see, then we can ask the computer, hey, what does this look like to a bird? And this has actually been done before. So for example, this was a study in the United States a few years ago where they wanted to find out, are there certain colors of LED lights, like on the left, that would keep birds away from runways at airports? And so what they did was they asked the visual perceptual model, and the model said, red and blue is going to stand out the most to this species. Then they built a very similar test shown on the right, where the bird had to fly to the left or to the right, and they had lights appear on either side. And what they found was actually the model was correct. The model predicted that blue and red would cause the birds to avoid the most. And that's actually what the birds did in the experiment. So just bringing it all together, and I'm almost done, I promise. We want to simulate window collisions in a novel flight arena and do it in a very naturalistic way. But we want to also train these visual perceptual models in a computer to predict how birds see different window treatments. And the reason for that is because these tests are expensive, right? It costs a lot of time and resources to go out and capture the birds and test a whole bunch of them and figure out what they see and interpret the data. We need to do that, of course, but wouldn't it be great if we could just ask a computer instead? And so if we do this enough times, the goal is through refinement, we come up with more accurate models, and we can ask models to define what makes glass bird friendly or not. So just some concluding thoughts to wrap up my talk. In my opinion, solving the problem of birds crashing into windows is one, not just for bird biology and people who study vision like me, but it's also for human psychology. We need to be able to convince people at home and at work that birds crashing into windows is unacceptable and we should fix this. And we also need our political leaders to be aware of this problem and take action. And so I think the birding community, such as yourselves, has a really important role to play. You have the passion and the knowledge about birds to get people inspired and want to care. But we have to go further than that. We need to document the problem where it happens. We need to show people the solutions that are out there and get people engaged. So I showed you this slide of pictures. These are buildings on my campus that I've monitored. And I want to leave you with just a sense of how I've managed to get some of these buildings retrofitted at Western. The way is through data. So I've been collecting data on our campus, just like Flap Canada does in Toronto, where I go out with volunteers and we're documenting where birds are hitting the windows. And through this evidence-based approach, where we know exactly where the problem windows are, we can inspire people to want to care and to realize this is where the solutions need to go. So I want to end on this slide. These were 100 and actually, I think it's close to 200 birds that I collected on campus in 2019, including species at risk. A wide variety of taxa are shown here. This image really got through to people. It connected with them. And so I think we need to come up with better ways of telling stories about collisions. We need to show people the problem, get them to care. This is about people just as much as it is about birds, if you ask me. The last thing I want to mention is we need to standardize this. It cannot be left up to individual municipalities like London or Guelph to become bird friendly. We should all be bird friendly. This should become just the way that we construct all new buildings. And so there's a campaign ongoing right now to update the Ontario Building Code. We've started a petition that I would encourage you guys to sign. It's on change.org. I'll paste the link in the chat afterwards. If you'd like to follow this petition and updates into the future, you can also subscribe to the Facebook page for it at Bird Friendly Ontario. And that is the end of my somewhat long presentation. I appreciate your patience in listening to me, and I'm looking forward to your questions. Thanks.
Well, thank you, Brendan. That was fantastic. It's so relevant, particularly at this time of year. I'm really glad for everyone to hear it and hopefully take action. Now we have quite a bit of time. I was hoping we do have Alessandra from Bird Safe Guelph. I know there are a lot of questions in the chat, but I would like Alessandra to just speak briefly about the Guelph initiative, the challenge, and the campaign. So Alessandra, please go ahead.
Hi, yeah, I'll just share my screen so you can see this short presentation. All right. All right, there we go. So I'm Alessandra Wilcox, and I'm going into my 4th year of wildlife biology and conservation at the University of Guelph. And I'm a representative of the wonderful club Bird Safe Guelph. And I wanted to talk to you about a little bit about our initiatives, as well as our exciting opportunities and events. So Bird Safe Guelph started with just 2 students, Shelby Bond and Alex Sutton, who took notice of bird collisions on campus and wanted to do something about it. Since Haley Wilson launched the club, our community has grown significantly within the past year, and we've managed to create some real progress. Right. So right now we have 2 main initiatives. The first is the University of Guelph Campus Initiative, and the main reason our club began. We aim to partner with the University of Guelph to create a campus that is safe for birds by retrofitting the highest risk buildings on campus, as well as changing building design policy so all future buildings on campus will be bird safe. Our second is partnered with Nature Canada's Bird Friendly Cities Initiative, which aims to certify at least 30 Canadian cities as being safe for birds by World Migratory Bird Day in 2022. We're working towards helping the city of Guelph become certified as a bird-friendly city. And the aim of this initiative is to teach community members about the issues of bird window collisions and start forming a community of bird people who demonstrate that they care about bird conservation. And we'll achieve this through community engagement, educational outreach, and community window retrofitting by supplying materials to make windows bird safe. And we've given out over 150 kits so far, with more to come. So I just wanted to acknowledge all of these wonderful organizations that have helped us fundraise and gain traction for our organization. With the provided funding and research, we were able to achieve so much and further our positive impact on bird conservation. So right now, we're running the Show Us Your Window campaign. It's a super fun event that started on April 1st and is running to May 15th. This is a contest that allows for a community to get creative and transform their windows at home to be bird safe. We're giving away over 60 free kits at the Wild Birds Unlimited in Guelph, and we started that at the beginning of the month, and there's 45 kits left. So, you can head over there and get your free kits and start with our contest straight away. Once we run out, there'll still be supplies available to buy at Wild Birds Unlimited as well. So winners will have the chance to win one of 3 prizes filled with goods donated from local Guelph businesses, including a $100 gift card to Wild Birds Unlimited. All you have to do is transform your windows at home following bird safe guidelines. And so just to reiterate what Brendan explained, so here's a wonderful example of one of our members creating a wonderful design that you can do at your own home. Yeah, so I'm just going to go over real quick some of the guidelines that we want to emphasize with this contest. So you can use feather-friendly tape, white oil-based markers, other tape, stickers, or any other creative solutions within the guidelines. And an important thing to note is that feather-friendly tape can only be applied when it's 10 degrees or warmer outside. So keep that in mind when you're applying these in the spring. It's starting to get a little bit warmer now. The design should be at least 5 millimeters wide and no more than 5 centimeters apart. Yeah, just like Brendan explained in his presentation. They must be applied directly to the outside of the window and cover the entire window surface. And we're using white for the purposes of this event because this contrasts with the dark surface of the window most effectively and provides the highest visibility to birds. So here's some good example. Well, here's a good example of a bird safe design, and here's a bad example, which we've already talked about, so I don't need to go further into that. Here's a beautiful creative design that someone came up with using white oil-based markers. And this is an example of the feather-friendly tape. So, once you're done decorating, take a picture of your new bird safe window and share it on Instagram with the following hashtags: bird safe Guelph and bird friendly cities. And you can, make sure to visit Wild Birds Unlimited. The prizes are also being picked up, or you can pick up your prizes at Wild Birds Unlimited as well. And here's our website, and if you have any further questions, you can email us, or you can direct message us on Instagram, and check out our website to go over the guidelines again. We have those listed. There's also links to wonderful websites like Flap or Feather Friendly, where you can see all these bird safe guidelines again and make sure that you're decorating your windows properly. And yeah, that is all. If anyone has any questions.
Thank you, Alexandra. That's fantastic. I'm excited.
Yeah, no problem. It's going to be really cool.
Yeah, it's so nice to see a group of people concerned about the same thing. Sometimes we feel like we're alone in our worries, and I'm really excited to see this gaining momentum. I would point to one thing with the lockdown.
That's what it's all about.
Yeah. Wild Birds Unlimited storefront is closed because all stores are closed, but certainly by phoning ahead, you can arrange to pick it up, I'm sure.
Right. Okay, yeah, thank you for saying that.
Good. Dean, if I could ask you to go through some of the questions for either Brendan or Alexandra, that would be great.
I'd be pleased to. So Brendan, we have some great questions coming in through different methods. Are window bird collisions primary migration issue, or is there still significant collisions at other times of the year?
Good question. So it's important to recognize collisions do happen year round. That's the short of it. In reality, our resident birds, our birds that stick around all year, their populations are relatively stable. It's the migratory birds that are exhibiting the most decline. And it seems like migratory species are at greater risk than a resident species. There's been a few studies that have made those species comparisons, and no one is really sure why. My thinking is that it might have to do with birds becoming familiar with their environment. So resident species tend to occupy the same local area throughout the year. And so they might learn where the hazards are. There's a window over there, and I know not to smack into it. Whereas with migrants, they're passing through, they're in a different neighborhood every day, they're traveling really fast, they're also exhausted. So it's complicated, but bird collisions do happen all year and all species are affected.
Excellent, thank you. Here's a question regarding windows and their design. So is there an effective non-reflective glass that provides good transparency from the inside, but poor reflection from the outside?
Yeah, so that's a great question. Typically, the reflectivity of windows comes from the glazing that's applied on the exterior pane of glass. Most windows are actually multiple pieces of glass sort of flushed against each other. There are certain types of glass that have lower iron in them, and they kind of look a little bit green. They will produce less of a reflection. So I encourage developers to incorporate those into new construction. The thing is, though, I talk about reflection on glazing, and this is kind of an ambiguous topic. It's not clear how reflection is actually measured, or if no one has really tested, is there certain reflectivity of certain pieces of glass that's more dangerous or not? Through my testing method, I would love to be able to answer some of those questions.
Excellent. Interesting. This question kind of relates back to what we talked a moment ago when you talked about when birds hang around, they get to know their environment. So person has asked, do birds learn from past mistakes? For example, other birds' mistakes. Do birds experience other birds hitting windows and therefore avoid them, or have near misses and learn from that?
I love this question, and I should have put it on my slide of ones that keep me up at night. I think birds do learn, but the thing is, learn what exactly? So if a bird hits a window on a specific house, does that mean that suddenly that bird is wiser to all windows everywhere? I don't really think that's fair. I think it may have identified one specific hazard. On the other hand, when I've tested those house sparrows in that little miniature tunnel I showed you, there was a clip of a bird that sort of looked right at the camera and was like, I'm not smacking into that, and turned around. That was a bird that had just done that. It had just flown the route. And I think it probably realized, oh, there's a barrier here. So I think there is a capacity for birds to learn. But going back to that example of resident species where they're hanging out in one environment, house sparrows and starlings are examples of birds that tend to occupy the same space for a long time. And coincidentally, they don't hit windows very often. I don't find many house sparrows dead. I don't know if that's because they're just reared in an environment where there's lots of windows, and so they learn, but not sure. I think that the problem of not recognizing reflections and what they are is pretty universal in the animal kingdom. There's only a few species like ourselves and other primates, certain like corvid species, dolphins, that understand reflection, but understanding a reflection is not the same thing as flying at breakneck speed and having to realize this isn't a real tree.
Understood. So further to that, because it's a related question, are there certain bird species that are at higher risk of window collisions?
Yes, there are. So there's been a few studies that synthesized across these huge databases of organizations like FLAP going out and collecting carcasses and keeping records of where birds are dying and how many. And it seems like there are certain species that are especially at risk. Ovenbirds, white-throated sparrows, dark-eyed juncos are examples. Nobody really knows why that is. We can sort of make some guesses about trends of where we find birds and at certain times of the year. But a tricky thing is we have to be able to account for the abundance of those birds. So for example, if we've got a ton of ovenbirds dead one year in Toronto, is that because there was an eruption of ovenbirds and there's just a lot of ovenbirds, or is that because they're disproportionately at higher risk? So it's a big question mark for me. There seems like there are differences across species, but nobody knows why.
So you've chosen house sparrows as your species.
Yep.
Are you able to extrapolate then the behavior of the house sparrow to other species, or further, why did you choose the house sparrow?
So a house sparrow, that's a tough question, and I appreciate you asking me because I know this is going to come up when I defend my PhD, and I should be practicing how I answer that. It's not fair to compare across bird species in a direct way like that, in my opinion. And this is a problem I have with the previous tests of collision deterrence, like in the tunnel in the United States, where they basically just test whatever shows up in the net, and they treat them all like they're the same thing. And we know that the vision of birds it's very different from ours, but even across bird species, it's super different. A chickadee and a cardinal and a house sparrow and a wren all see the world in a very different way. So what is maybe very conspicuous to a cardinal might not actually be for a species like an ovenbird that is at risk. I chose the house sparrow not because it hits windows often, obviously it does not, but it's a species that is easy to work with. because I'm developing new methods from scratch, you know, it's much easier to say, I'm going to go out and catch a bunch of house sparrows at Home Depot that nobody wants than to get a permit to go and catch ovenbirds to do all this exploratory, you know, can we make this work or not? But because house sparrows have been studied so much for this reason, their visual system is very well defined. So those computer models, the program that I'm trying to train to see like a bird, we already have most of the measurements of a house sparrow's eyes and their brain to be able to calibrate those models. Whereas that only exists for maybe a dozen species, and none of the super at-risk species for collisions have been quantified that way yet. So it would be nice to generalize down the road, but we're going to need to take some measurements of birds' eyeballs, and I'm not there yet.
So you're already gunning for your postdoc.
Between you, me, and the wall, it would be fun, sure.
Okay, I have a technical question here from Alan. So he's placed white dots 2 inches apart horizontally and 4 inches of vertically spacing and had no collision so far. Would placing them 4 inches apart and 2 inches vertically be as effective? And that may be to you and Alexandra.
So, yeah, I mean, if Alexandra wants to jump in, my thinking on that is it's an empirical question. I don't know. It's the sort of thing I would love to test, you know, get some glass treated in those ways and figure it out. I'm not confident enough in the previous data to say that, you know, yay or nay. I feel like the principle of anything you put on your window is going to be better than nothing applies here. And so white dots on a black background might be enough, you know, at approximate spacing for a bird to recognize this is a solid thing that I can't fly through. But maybe you just haven't had a lot of hummingbirds or kinglets at your house in the past year. It's really hard for me to say.
Alessandra, do you have anything to add to that? No.
Yeah, I mean, not really. I think Brendan really hit home with that one. I haven't read anything that kind of dictates whether either is effective. So
this all comes from what we have called in this industry the 2x4 inch rule. And I've spoken to the people who developed that rule, and it seems like it works well enough that we've sort of stuck with it and we tell people about it because I think it's easy for folks to grasp, but it's arbitrary, right? What if it's the 2.2 inch by 4.1 inch rule? Like nobody really knows, and that hasn't been factored in. I recommend sticking to 2-inch spacing if you can.
Excellent. And I know we're coming short of time, and I have a couple of questions here that is about advocacy and the actions we can take. So
yeah,
perhaps you can talk about how challenging it's been to educating municipal officials and leaders to change bylaws.
Oh man. I never fancied myself a politician, but I had to kind of think like one for the last while. It's hard. It takes a long time. It's very slow. And often it just comes down to serendipitous, you know, opportunities where you make the right contact with the city councilor who cares about birds or nature, or a party is looking for something that they can add to their platform. I have had the fortuity to be able to do this in a community in London that really cares about nature and birds. So I get support from all over the place because people recognize this as a problem and something they want to be cognizant of and contributing to. The bird-friendly bylaw in London has been in the works since 2017. And I know what it's supposed to say, and I know this is how it's going to shake out in the end, but it takes a really long time for municipal politics to get the ducks in a row. I always think that showing people data is really valuable. If you can say, here's the proof, then it's hard to argue with evidence. If you can make their job easy for them so that they don't have to understand complicated things and they don't have to reinvent the wheel, that goes a long way too. So if we can say, hey, Toronto already did this, you know, let's just copy their bylaw. Often, you know, okay, yeah, that's an easy box to check off. Don't get discouraged if things move slowly. That's the number one thing I remind people. Stuff takes time. community support helps a lot too. And I try and be as public as possible about my advocacy because there is this sense of investment in what I'm working on. It's not just Brendan, some grad student coming at them anymore. This is about the community and something that we all care about.
Excellent, thank you. One final question. I believe you mentioned keeping your bird feeders within 3 feet of the window. Any further comments about how bird feeders may contribute to window strikes and any more actions we can do?
Yeah, so feeders within 3 feet or 1 meter of the window is good. Keeping your feeders clean is really important. I feel like a lot of people who feed birds don't realize that you're asking all of your birds who visit to eat with the same fork. And odds are there's some bird in your neighborhood who isn't brushing its teeth and ends up with salmonella or something gross, and it can become a major contaminant in your food. And what happens then is birds often will get these really crusty, gross eyes and they can't see. So they end up on the ground or they're flying into windows because they can't look where they're going. So keeping your feeders clean as well as appropriately distanced from your window matters a lot. I mean, I haven't talked about them, but cats are the leading way that people kill birds. So if you've got feeders in your backyard, you should be very conscious of letting your cat outside. If you have people on your street that are letting their cat outside, it's worth having a conversation with them about it. That's about all I can think of right now.
Well, thank you very much. Great answers to the questions. Val, I'm going to pass it back to you. I know we have more questions, but I think we're out of time.
Yes, I suppose we should wrap it up eventually. Well, thank you very much, both of you. Again, a tremendous and relevant subject at this time of year, although I've learned all times of year are equally, well, maybe not equally as important, but always important to take care of our windows and our birds. So thank you. I guess that wraps up this month's meeting, and we will see you next month here. Have a great night, everybody.